So this is that steel MS660 I'm working on. I'm going to do some cut the squish and stuff, but I had this piston off and I had an opportunity to show how I put circlips back in. And there's tools for doing this. You put the circlip in the tool and you just give it a push and it pops it on there. And those tools are like $100. I tipped the piston back this direction and I put the open up kind of over there and I kind of poke that side of it in there. I'll hold it with my thumb and there's a little notch in the piston here and I put my screwdriver in there, put the blade flat to the pin or the clip and I stick the corner of the blade in there, and the blade of the screwdriver, the face of it, is actually, you know, on the clip. And I give it a little twist and a little push, and I kind of messed this one, but they pop right in there. You don't have to force it. If you're squeezing it with a pair of pliers, you're deforming it, and that's not the correct way of doing it. And to take it out, I use just a pick. It's just a scribe, and I put my finger over the whole thing, stick it in that notch, my thumb over it, and I just wiggle it in there and take it out. And you know, we do zing these every once in a while. I mean, nobody's perfect, right? So I always have some extras on hand, but put that up there in that kind of corner range. Put some pressure on it with my thumb, stick that screwdriver in there and snap it right in. It's just that easy. So that's that. I just wanted to show that quick. Had the opportunity to do so. We're going to set it up here to do the chicken squish and cutting the squish band. The base of the cylinder has been cut, and so we're just moving on using my newly made vise here. So kind of the first time, so there'll be a little bit of getting used to the vise through this too. So kind of how I've decided to use the vise with a wrench. We're going to see how that goes. So I made up these little studs. Turned around here so I can see. Made up these little studs. I just cut the heads off from the screw and cut a screwdriver slot into them, and I put those in to align the cylinder. I put one in this corner and I put one in this corner. So I don't have to put bolts in and out, in and out, in and out. It speeds things up. I screw them down in there quite a ways. You don't have to stick up very far. So then we put the cylinder on there, no base gasket, and of course I've got a clearance issue, so we're going to take care of that first. That'll be the first step. So seeing I've got the base now, the transfer tunnels are touching on the edges. It's almost this always on the right side on 66, and it'll be right in this area here or up here. And sometimes there's some on the other side as well, kind of down in this area where it hits in here. And I believe it's on this side first. my flashlight in there and we'll look for that. We have to take care of all these problems that when we start modifying stuff. So I believe that it's up here. So we're going to do that first. First things first, right? So we get the right bit on here, right tool. We'll use this one. This is a aluminum hog. I like these bits. They cut fast and relatively smooth. So we're looking at this side, up in this area. And I know that I'm going to have some in here, so I'm going to go ahead and do some of that too. Alright, we'll see what that does. We'll set that back on. And I rock it, and I'm still hanging up somewhere. It's not sitting on there flat yet. A little more in this area. Yeah, I can rock it sideways a little bit, and you know, if I'm touching front and back, I can feel that, you know, that, and I got some movement that way. That means that side is clear, and I can't rock it this way, and it's obviously not on both flats, so we still got more in this area. There we go. Now it clears. I can hold it flat. It's staying flat, and I can still rock it to this direction. So I've got a little clearance there. So you got that. All right. So we're gonna set up a degree wheel, and I use a wire, and you can mount the wire somewhere, pointer wire, and this is my favorite spot. The wire's getting a little weak there, but it'd work, and then that goes on there, and I want somewhere around point open of the port, and I set this somewheres in the 0 position over here, so my 0 is somewheres in there with my wire, and then we'll be kind of set up to time it here. And let's see if I can get you where you can see the end of that port. Probably not, but we'll try. Let me see. So you can see that. I'll add a little more light to it. And I'm going to go by what you can see, not with what I can see. So what you're looking for is to time the intake is to make sure that cylinder's all the way down. And you can see the port's open, turn the motor backwards, closes it. I want to find a spot where it just is barely at where it starts to open. You know, it's open a little bit, right where it just barely starts to open. And this is where everybody reads them different. You know, it's just relative. So now we're going to move our pointer up here to our 0. I'm not touching anything. I don't want it touching the wheel, because that'll move it. My wire's going to break on me, I think. And that's 0 there. Let's get back in here again. See what you can see. Now we want to rotate it around open, and the cylinder lifts up because we haven't cut squish yet. Piston's coming back down, and to just at a point to where it's just starting to close, and that's duration. It's degrees of rotation. Okay, we come back over here, and we started at 0. Here's 90, 110, 20, 30, 40, 50, 60, about 66, 67 degrees. 167 degrees. That's about what we got in there for duration right now on the intake. So that's, you do that with all the ports. That's how you measure in duration, or you can do a top down from top dead center, degrees from top dead center to a point, to the point of port open or port closed, or however you want to do it. But I do everything in duration. I'm going to teach duration. I'm not going to go any other direction with it. So let's get back to the squish here. We obviously have some interference here, and so I'm going to turn it forward. I'm going to loosen up my screw again. I'm going to turn it forward till it's up against the piston is up against the squish. I'm going to set somewhere over here into to 0. Tighten my screw back up again. And there's more than one reason for me to do this. Oops. And it's mainly to know that I'm cutting the squish correctly. Alright, so that's 0, right? So let's turn it over past that point and then back it up. So now I'm past top dead center and I'm backing the motor up. And I've got 29 about degrees there. Here we're at 0, going forward. We roll it over, hold the cylinder down, about 29 degrees of interference. So when I start to cut the squish out of here, I'll cut like 8 thousandths out, and I'll come back, stick it back on there, and I want to see that number change. I want less than 30. That way I know that I'm cutting out to the edge of the cylinder and the piston's not hitting it, and then my measurements from there will be accurate. If I just went by how this felt and I kept cutting and kept cutting and kept cutting, and I'm not cutting all the way to the edge and the piston is hitting that lip in there, I'll cut way past where I need to be before I actually get my brain working to know that something's wrong. So let me cut some out of it and I'll come back. So I got my mandrel set up. I got it in my vise. I'm solid bench here. It doesn't move. It's bolted to the wall. And I got it set for, I don't know, 4,000 or 6,000, something like that. The first initial cut is kind of misleading, but it's around 4 thousandths. For me, it really doesn't matter how much that first cut is, but I'll do another 4 after this. And like I said, I'm pushing against the cutter and down a little bit. And you don't have to push hard, but firm, you know. And I back it up. That kind of clears the chips from the cutter, so it cuts a little smoother. Yeah, I can tell when I'm bottomed out. And then I'll turn this another 2 increments on my deal here, and it's another like 4 thousandths. And I'm not real concerned about it being real clean right now, but you know, let's see my light down here. Where is it? There it is. So you can see that we're cutting some out of there. We're not to the full width of the squish band yet. You'll see that band get wider as I cut. As stated in the other video, this squish band is pretty irregular. It's not a real good squish band, so let's go back to the saw. Alright, so we cut some out of Squish band, 8 or so thousandths, and so now we want to know for sure that we're cutting all the way to the edge of that cylinder. And so we didn't touch anything here, it's set just the way it was before. And we move this forward, and you can see we're about 2 degrees off from the 0, and we were at 29, and we're about 2 degrees off there. So if we go back here and we move this to 0 again, we roll it ahead, back it back up, we're actually at about 25. So that ensures to me that we are cutting out to the edge of that cylinder, or at least close enough that it doesn't interfere with the piston, and I'll continue to cut from here. I always check this to make sure that I'm not making a mistake. I've made that mistake in the past and cut way past where I wanted to be, and you learn from your mistakes. So I'll bring it back, I'll cut some more on that. And then we'll do some measuring on Squish.